Hey y'all, sorry I couldn't be here with y'all today. So you just got finished with notes, and if you need to practice your problems on wave calculations, and I was worried that you would get stuck, and so I wanted to make sure that I worked a few of them with you. And so you've got this little sheet of paper. I'm going to work 3, 7, and 11, and I'm sorry this is going to be on 2 videos. I know, my storage, it sucks. Sorry y'all. So let's look at 3. Okay? Number 3 says, what is the frequency of a wave with a wavelength of 5.4 times 10 to the negative 5 centimeters? Okay, we've got some formulas up here. We've got speed of light, which is c. Speed of light equals wavelength times frequency, where wavelength is lambda, frequency is Greek letter nu. C is the speed of light. We've got an energy formula. Energy equals Planck's constant times, again, Greek letter nu, which is frequency. There's 2 constants in these formulas, speed of light, which is 3.00 times 10 to the 8, and Planck's constant, which is 6.626 times 10 to the negative 34 joules per hertz. And so let's look at number 3. I always read the question and figure out what's being asked first. What is the frequency? Frequency, we don't know. Of a wave with a wavelength, wavelength equals 5.4 times 10 to the negative 5 centimeters. Now, I'm going to figure out what formula I need. Well, there's only one formula that has wavelength and frequency, and that's the speed of light formula. So I'm going to write that here. So we see we're looking for this. We have this. Oh, this. We do have that, though. That's the speed of light constant. 3.00 times 10 to the 8 meters per second. Now, your constant is going to dictate what units you use. This says meters right here, so this has got to be meters. We've got to convert this. That's why I'm choosing this one to work with you. So let's do that first. 5.4 times 10 to the negative 5 centimeters. Centimeters comes on bottom. We need a base unit with every step, plus we want it to be in the base unit. Which one's bigger? Metric's bigger, meters bigger, sorry. And then centimeters are 100 centimeters. There are 100 centimeters for every meter. Or if you're doing the great and mighty King Henry died by drinking chocolate milk under nice pretty flowers, you see that centimeters has a 2 beside it. That's 1 times 10 to the 2. Let's put that in a calculator. 5.4, oops, my bad. E, negative 5. This is on bottom, so divide. 1, E, 2 equals 5.4, 5.4, E, negative 5, divided by 1, E, 2. 5.4 times 10 to the negative 7, and that is now meters. We're not going to use this. We're going to use this. So let's go back to our formula. I'm going to rewrite it. So it's down here where my work is. Okay? We are solving for frequency. So we need to get wavelength onto the other side. We want frequency all by itself. So right now we notice that they're being multiplied. So we need to divide them to move the wavelength over. Those cancel. Now I have frequency is speed of light over wavelength. My frequency, speed of light, 3.00 times 10 to the 8 meters per second. We're going to divide that by our new wavelength we calculated, 5.4 times 10 to the negative 7 meters. Put that in the calculator. 3.00 E8 divided by 5.4 E negative 7 equals. Okay? Oh, I know. Y'all don't want to hear this. Sig figs. Don't use your constant. Use your given. Your given has 2. Our answer needs to have 2. So I'm going to round that to 5.6 times 10. Now over here on your calculator, you'll see that itty bitty times 10, and then there's a 14. That means it's scientific notation. Don't forget it, because that's a huge difference. We see our meters cancel. That leaves seconds on bottom, which is like saying 1 over second, which if you remember from your notes, that means hertz. Frequency is in hertz, so that's good. That lets us know we did it correctly. Okay? So that's using your speed of light formula. Now let's work a problem where we're going to use our energy formula. And I have chose number 7 for that. Okay? Let's read number 7. What is the energy of 7.66 times 10 to the 14 hertz wave? So our questioning word is by energy, so energy is what we don't know. And then we do know 7.66 times 10 to the 14 hertz. It doesn't tell us what that is. We have to rely on our knowledge. Hertz means frequency, so that means Greek letter nu, frequency. If we look up here, that does no longer fit our speed of light formula. It fits our energy formula better. So I'm going to write that formula. E equals h times nu, Greek letter nu. H is Planck's constant. That is a number we have. So I'm going to list that over here. 6.626 times 10 to the negative 34 joules per hertz. Now I have everything we need, and yay, our formula, we don't have to redo it. It's written exactly the way we need it to be. Energy equals Planck's constant. So I'm going to write that number first. Joules divided by hertz. And I'm going to multiply that by our frequency. 7.66 times 10 to the 14 hertz. Hertz cancels. That leaves us with joules. Put that in the calculator. 6.626 E negative 34 times 7.66 E 14 equals. We've got E equals. Now again, dreaded sig figs. Constant, don't count those. Count the given. 1, 2, 3. So I am going to round that to 5.08 because the next number is a 5 after that 7 times 10 to the negative 19 joules. Joules is a unit of energy, so that looks good. I really hope this helps y'all. And again, I'm sorry this is in 2 videos. Can y'all hear Mr. Carter next door? He's still so loud. I hope y'all have a great weekend. Hope this helps. Bye.